We all travel through time. Every moment, every breath we take, we are moving forward, second by second, minute by minute, hour by hour. It's a journey that never stops, a relentless march into the future. Every second, we move further into the future. The ticking of the clock is a constant reminder of this unending progression. Time waits for no one, and we are all passengers on this one-way trip. But what if we could control this journey? Imagine having the power to pause, rewind, or fast forward through the moments of our lives. What if we could choose the exact point in time we wanted to visit? What if we could go backward to see the dinosaurs or forward to meet our great-great-grandchildren? The possibilities are endless. We could witness historical events firsthand, or explore the unknown future. This is the dream of time travel. It's a concept that has captured the human imagination for centuries. The idea of bending time to our will, of stepping outside the linear progression of past, present, and future, is both thrilling and mysterious. For centuries, humans have been fascinated by the idea of time travel. From ancient myths to modern science fiction, the allure of moving through time has been a constant theme in our stories and dreams. It has been a popular theme in stories, movies, and TV shows. From H.G. Wells' The Time Machine to blockbuster films like Back to the Future, time travel has been a source of endless fascination and speculation. But is time travel really possible? Can we actually bend the fabric of time and space to our will? Or is it just a fantastical notion, confined to the realm of science fiction? Or is it just science fiction? The line between what is possible and what is imagined is often blurred. Science fiction has a way of inspiring real scientific inquiry, pushing the boundaries of what we believe to be possible. The answer, like many things in science, is complicated. Time travel as a concept challenges our understanding of the universe. It forces us to confront the very nature of reality and our place within it. To understand time travel, we need to understand time itself. What is time? Is it a constant, unchanging flow, or is it something more fluid and malleable? These are questions that have puzzled scientists and philosophers for centuries, and that means exploring some of the most mind-bending ideas in physics. Concepts like relativity, quantum mechanics, and the nature of space-time all play a role in our understanding of time travel. Join me as we embark on a journey through time. Together we'll delve into the science, the theories, and the stories that have shaped our understanding of this captivating concept. We'll explore the science, the stories, and the possibilities of this captivating concept. From the pages of classic literature to the cutting-edge research happening in labs today, we'll uncover the mysteries of time travel and imagine what the future might hold. Albert Einstein's theory of relativity revolutionized our understanding of time. Before Einstein, time was considered a constant, ticking away uniformly for everyone, everywhere. But Einstein's groundbreaking work showed us that time is much more fluid and mysterious than we ever imagined. Einstein showed that time is not absolute. Instead, it is intertwined with the fabric of space itself, creating what we now call space-time. This revelation changed the way we perceive the universe. It is relative to the observer. Imagine two identical clocks. One is stationary on Earth, while the other embarks on a journey through space. One stays on Earth, while the other travels into space at incredibly high speed. As the spacecraft accelerates to a significant fraction of the speed of light, something extraordinary happens to time. When the traveling clock returns to Earth, it will show less time has passed than the clock that stayed put. This phenomenon, known as time dilation, is a direct consequence of Einstein's theory. This is called time dilation. Time dilation occurs because at high speeds, time itself slows down relative to an observer who remains stationary. Time dilation happens because time slows down at high speeds. The faster you move through space, the slower you move through time, relative to someone who is not moving as fast. It's also affected by gravity. Massive objects like planets and stars warp the fabric of space-time, causing time to slow down in their vicinity. The stronger the gravity, the slower time passes. Near a black hole where gravity is immensely strong, time can slow down to a crawl compared to regions with weaker gravity. Another mind-bending concept is the wormhole. Wormholes are theoretical passages through space-time that could create shortcuts for long journeys across the universe. Imagine a shortcut through space and time connecting two distant points. If wormholes exist, they could potentially allow us to travel vast distances in a fraction of the time it would normally take. If wormholes exist, they could potentially be used for time travel. This means we could theoretically travel to the past or the future by navigating through these cosmic tunnels. However, there are many challenges. The existence of wormholes is still purely theoretical, and even if they do exist, we have no idea how to stabilize them for safe travel. Wormholes are theoretical, and we haven't observed one yet. Scientists are still searching for evidence of these fascinating structures in the cosmos. Even if they do exist, they might be unstable and dangerous to travel through. The intense gravitational forces at the entrance and exit of a wormhole could be catastrophic for any traveler attempting to pass through. Time travel has been a popular theme in fiction for centuries. From H.G. Wells's The Time Machine to the Back to the Future movies, our imagination runs wild with the possibilities. These stories explore the paradoxes and consequences of messing with the past or future. What happens if you change a key event in history? Can you meet your past self without creating a paradox? Time travel stories often serve as cautionary tales. They remind us that even small actions can have ripple effects across time. They also make us think about the nature of free will and destiny. While we haven't built a time machine yet, there are real-world experiments that touch upon the edges of time travel. For example, scientists have used atomic clocks to measure time dilation at incredibly small scales. These experiments confirm Einstein's theories and show that time is indeed relative. Researchers are also exploring the strange world of quantum mechanics, where particles can exist in multiple states at once. Some theories suggest that quantum entanglement could potentially be used for sending information backward in time. While these experiments are a far cry from traveling to the past, they demonstrate that the universe is far stranger and more complex than we could have imagined. Section 5. Could we change the past? The idea of changing the past is a tantalizing one. I mean, what if we could go back and prevent a tragedy or right a wrong? However, changing the past raises many paradoxes. The most famous is the grandfather paradox. What would happen if you went back in time and accidentally killed your own grandfather before your parent was born? Would you cease to exist? These paradoxes suggest that changing the past might be impossible, even if time travel is possible. It's possible that the universe has mechanisms to prevent such paradoxes from occurring. Section 6. The grandfather paradox. The grandfather paradox is a thought experiment in physics and philosophy that illustrates potential contradictions that might arise from time travel. It is one of the most famous and frequently discussed paradoxes in the realm of theoretical physics and time travel narratives. The paradox is named for the classic example. What happens if a time traveler goes back in time and kills their own grandfather before their parent was conceived? This scenario raises profound questions about the nature of causality and the fabric of reality itself. If the grandfather dies, the time traveler would never have been born. This means that the very act of traveling back in time and committing the act would prevent the time traveler from existing in the first place. But if the time traveler was never born, they couldn't go back in time to kill their grandfather. This creates a loop of events that defies logical explanation and challenges our understanding of cause and effect. This creates a logical inconsistency or paradox. The grandfather paradox is a prime example of how time travel can lead to situations where the cause and effect relationship becomes tangled and contradictory. The grandfather paradox highlights the potential for causal loops and inconsistencies when considering time travel. These causal loops, also known as closed time-like curves, suggest that events can be self-perpetuating, leading to endless cycles of cause and effect that defy conventional logic. It suggests that altering the past, especially in ways that directly impact the time traveler's own existence, could lead to logical contradictions. This paradox has been a central theme in many science fiction stories, exploring the complexities and potential dangers of meddling with time. The grandfather paradox serves as a cautionary tale, reminding us that the consequences of time travel are not just theoretical, but could have profound implications for our understanding of reality. Section 7. Time travel and you. Time travel might seem like a distant concept, something out of science fiction, but it has profound implications for our understanding of the universe and our place in it. If time travel is possible, it means that the past, present, and future might all exist simultaneously. This challenges our linear perception of time and raises questions about free will and destiny. Even if we never build a time machine, exploring the possibilities of time travel can expand our minds and inspire us to think differently about the universe and our place within it. Section 8, the future of time travel. So, what does the future hold for time travel? Will we ever be able to visit the past or future? It's impossible to say for sure. However, history has taught us that scientific progress can be unpredictable. Breakthroughs can happen unexpectedly, opening up new possibilities that were once considered impossible. Perhaps one day, we will unlock the secrets of time travel. Until then, it remains a captivating concept that continues to spark our imaginations and push the boundaries of our understanding. Section 9. Keep looking up. As we conclude our journey through time, I encourage you to keep asking questions, keep exploring, and keep looking up at the stars. The universe is full of mysteries, and who knows what incredible discoveries await us in the future. Perhaps time travel will forever remain a dream. Or maybe, just maybe, it's a possibility waiting to be unlocked. Only time will tell.